Hello everyone, it is still me, Sir Robinson, your partner learning mathematics. In this video, we are going to learn more the chain rule, what other problems that is appropriately solved using the chain rule. So again, welcome, more chain rule problems. Okay. So I have here a new problem. So I believe this level 2 is kind of complicated compared to the previous example. So my function is this one, that is y is equal to the square root of 2x plus 3 all over 5x minus 1. So obviously my function is under radical sign. And we believe in my previous video, we can able to convert whenever our problem is under radical sign. We can able to convert this one in the power, okay, or in the exponent. And this problem is appropriately converted using this one. In my previous video, you have already learned how to convert whatever inside the radical sign in the form of a power or in the form of exponent. So from here, we converted this one in that form. So basically, what makes it appropriately solved using chain rule simply because we have outside and inside functions. So let's identify the outside and inside function in this problem. So obviously, we already converted to whatever inside the parenthesis, that is your inside function. So whatever outside the parenthesis, as you can observe, we don't have anything here, but we have an invisible one. That's always in mathematics. So we have an invisible one. So therefore, we have the outside function, which is the invisible one, and the 1/2. That's how a chain rule works, right? You identify your outside and inside function. Whatever the inside of the parenthesis, that is your inside function. Whatever the outside of the parenthesis, that is your outside function. So now we already know what are our inside and outside function. So I believe I believe we are now ready to solve this in the chain rule using the steps that I've told you in my previous video. Okay, so step number 1, we have to derive the outside function. So when you say outside function, only those things outside the parenthesis. So it's something like this. So what we did is we just left whatever inside parenthesis blank. What we are concerned in step number 1, only whatever outside. So that is 1/2, and of course the invisible one outside the parenthesis. So that is our outside function. So for step number 1, we have to derive, or we have to get its derivative. So simply, since 1/2 is a power, so meaning we can use the power rule. So we have to put this one here. We have to multiply our power by whatever inside here, and that is 1. So 1/2 times 1, that is 1/2, and we have to deduct 1 to our 1/2. So that is 1/2, and 1/2 minus 1, that is negative 1/2. Okay, so we use power rule. So as you can observe, we are now done with step number 1 by deriving the outside function. Okay, so for step number 2 in chain rule is we have to copy the inside function. So we know what is our inside function. So we have to copy first our step number 1. So this is the result of our step number 1. Okay, that is the result of your step number 1. And for step number 2, you have to copy, only copy, nothing to do with it, just only copy your inside function. And our inside function from our original function is this one, 2x plus 3 all over 5x minus 1. And we have to copy it in the parenthesis, or we have to fill in the parenthesis. So it's something like that. Okay, so we already done with step number 2 by copying what is our inside function. So if you're done with step number 1 and step number 2, so without further ado, let's proceed to step number 3. What is step number 3? We have to multiply the derivative of the inside function. So we have to find the derivative of the inside function. So, but before that one, we have to identify what is our inside function. Our inside function is this one, right? 2x plus 3 all over 5x minus 1. And for step number 2, we have to multiply the derivative. As you can observe, our inside function, or this one, our inside function is in the form of a fraction, or that is a rational function. Once that is a rational function, we are going to use the quotient rule. That is f prime g minus g prime f all over g squared. We have to solve that one. So in short, in chain rule, all the rules that we've learned in my previous video, we have to apply this all. We still have to apply as we observe some of the appropriate functions in the with respect to those rules that we've learned. So since our inside function here is a rational, or in layman's term that is the fraction form, meaning automatically what we're going to use is the quotient rule. And again, do not forget how quotient rule works, because this is our quotient rule, f prime g minus g prime f all over g squared. Okay, so how it works again, so you have to identify your f. Your f in the quotient rule is always your numerator. And what is our numerator in the inside function? That is 2x plus 3. So we have to identify its prime or its derivative. So what is the derivative of 2x plus 3? That is 2 from 2x, or using the identity rule. And for the derivative of 3, that is 0 because of the constant rule. Okay, so we are done with f and f prime. Now let's identify our g. So g always in the quotient rule is our denominator. Again, g is our denominator. So we already done with our g. Let's identify its g prime or its derivative. What is the derivative of 5x minus 1? That is 5. 5x from identity rule, that is 5. And the derivative of negative 1 is 0. That is why the g prime is 5. Okay, since we already done identifying our f prime, g prime, so let's try to substitute here in our formula. So by substituting, let me erase some of this writing. So there you have it. So we are done identifying this one. So we have to substitute it from here. Okay, so what is your g f prime? F prime is 2. Very good. That is the g, or the original function, or your denominator. That is 5x minus 1. You copy minus sign. What is your g prime? Your g prime is 5 multiplied to f. Your origin or your numerator, that is 2x plus 3. And in your denominator, you have to square your g. Your g here is, or your denominator is 5x minus 1, and you have to put squared. So that's how you do it, by substituting in the quotient rule. So since you are, I know that you already know that one by learning the quotient rule in my previous video. Okay, so we are done substituting in the quotient rule. So what we're going to do, just do manipulation, or you have to simplify this one. So this is 2, but this one you can distribute 2 in this term and 5 in that term. So what is the result now? The result now is 10x minus 2 by just distributing. Distribute it here and distribute it there. So that is the result. Copy minus sign, and 5 you have to distribute it there, and also to 3. So the result is 10x plus 15. So continue simplifying with your problem. So you have to distribute the negative sign on the left side or on the right side of your third or your numerator. So it become negative 10x, negative to 15, that is negative 15. And you copied whatever in the left side. Okay, so same thing, you have to continue simplifying. Observe that I have positive 10x here and I have negative 10x. So meaning we're going to get the difference of the two, that is 0. So what is the remaining now is the negative 2 and the negative 15. And negative 2 minus 2, that is negative 17. And just copy your denominator. In short, using the quotient rule, the result is this one. In short, that is the derivative of your inside function. The derivative of your inside function is negative 17 over the quantity of 5x minus 1 squared. Are we done? No, we are not done yet, because what we solved in this part, is the inside function, or the derivative of the inside function. Since we are done solving the derivative of the inside function, let's go back to step number 3. Let's go back here. Okay, let's go back here. Step number 3. What is the step number 3? Meaning you have to multiply the derivative of the inside function to step number 2. But before that one, let's copy step number 2. Okay, so that is now the step number 2. We just copied whatever inside the step number 2. So after copying step number 2, so I copied it again. After I copy whatever in the step 2, you have to multiply whatever the result or the derivative of your inside function. Earlier, we already solved the derivative of our inside function, and that is this one. This is the derivative of the inside function. Okay, so we are done with step 1, step 2, and step 3, and the result is this one. But as you can observe, it's kind of messy, meaning you still have a power of negative, and so on and so forth. Again, do not end with like that because it's a kind of messy. You have to simplify or do some, or you have to do some algebraic manipulation. Okay, let me erase the writings for a while. Okay, there you have it. Yes, this is now our derivative. But again, let's do some, or let's clean this one by doing some manipulation. Okay, so let me erase some part here. Okay, there you have it. I will put this one here. Okay, again, so what we did earlier is we used the chain rule, but we ended up like this. Okay, so we ended it as our derivative, but take note that we can observe some negative exponent, or it's kind of messy. So what we're going to do is to apply some algebraic manipulation in order to clean the term or our answers. Okay, so for some textbooks it is acceptable, but better to do some algebra to make it even more clean in our eyes. Okay, so as you can observe down here, what is the first step that we're going to do is to make our exponent positive. That is negative 1/2. And take note, negative 1/2 is for numerator and denominator down here. To make it positive, the easiest way to do is to get the reciprocal of your numerator and denominator, or in layman's term, you have to interchange the position. Whatever in the numerator, put that one in the denominator. Meaning you have to interchange the position of your numerator and denominator. For 2x plus 3, since that is your numerator, you put that one in the denominator. And also 5x minus 1, since that is your denominator, you put that one in the numerator, or interchange the position to make your power here positive, since that is negative 1/2. That is our first goal. So after interchanging the position of your numerator and denominator, it will become like this. Okay, so look, your power now here is positive 1/2. Why? Because your numerator and denominator here is already interchanged. Okay, so look, your 5x minus 1 here is now your numerator, and your 2x minus 3 from numerator, it is now your denominator. So that's the easiest way to do to make the power positive. Okay, so let me erase it for a while. There you have it. Okay, take note that 1/2 here, based on the algebra rules, is we have to distribute that one in the numerator and denominator, since that is good for them. So you have to distribute it one. So once you distribute it one, it will become like this. So 1/2 is well distributed to numerator and denominator. So it will become 5x. So everything or other part of this term are still the same. Okay, so we first solve this negative 1/2. So by distributing 1/2 to numerator and denominator, it will become 5x minus 1 raised to 1/2 and 2x plus 3 raised to 1/2. So that's the rule of distributing power. Okay, so after that one, since we already distributed that one, let's try to do more manipulations. Okay, so what happened? What we did is we simply multiply this one. We simply multiply 1 to 17, since the power here is 1, so you can multiply it directly. And you just copy 2, and this one we put that one inside here, so we just do multiplication or combining possible terms that can be used in solving this problem. Okay, so as you can observe, in this part you have 5x minus 1 raised to 1/2, and also we have 5x minus 1 here raised to 2, meaning same term, different exponent. Take note that, remember that in your algebra, example, x raised to 2 all over x raised to 3, that is equal to 1 over x. What happened? We all know that we can divide that one. They are both x's, what are we going to do with the power? You have to subtract the power. So take note that in the numerator you have x times x, 2 x's, right? All over, how many x's in the denominator? We have 3. So x times x times, so let me erase that one. Okay, so that is times x. Okay, so you can erase, you can cancel that one. So what is the remaining in our numerator? Nothing but 1. In our denominator we have x, or in short, we simply deduct 3 minus 1 minus 2, or we simply deduct the power when dividing terms or polynomials, right? If you still remember, so that is 3 minus 1, that is 1. We put that in the denominator since our denominator is greater compared to our numerator. So what am I trying to say here is, since you have same term, you can divide it 1 by deducting the power. So same thing here in our term. Let me erase that one. Same thing here, we have same term, 5x minus 1 and 5x minus 1. In short, we can divide this one. How to divide? By subtracting the power. The power is 2 and 1/2. So if you're going to subtract that one, 2 minus 1/2, that is 1.5, or that is 3/2. Okay, so whatever this one, just copy. What happened here is we divide this one. We divide this one by subtracting our power. So since our whatever in the denominator is greater than to the numerators, it will remain here. So why what happens, or why it becomes 3/2 or 3 over 2? Simply because 2 minus 1/2, that is 1.5, or in improper fraction, that is 3/2. Okay, so why 1 in the numerator? Because whatever in the numerator now here is nothing but 1. Same thing here. We already canceled x2, but still we have invisible 1 outside. So that's what happens right here. Okay, so we already simplified everything. We make our exponent positive. So let's continue simplifying. We believe that we can convert this one in the form of the square root. Also with this one in the form of square root. And I know you know how to do it based on my previous video. I do hope you take down how to do it. Same thing here. From here, we converted down here. So same thing, vice versa. From here, we have to convert in the form of square root since the power is an exponent. So in this form, in this form, or from this form, let's try to see how it looks like. Okay, so what happens from here, this form, is I multiplied 17, negative 17 times 1, or let me erase it for a while. There you have it. Okay, from negative 17 to 1, or multiply, that is negative 17, and 2 I multiply in this term, or I just combine since that is multiplication. So that's why it becomes like this. Okay, so continue simplifying. Let's make this power more appropriate to the most appropriate form. Okay, so it will become like this. Numerator is 17. So 2, since we believe that the power of 1 up, we can able to make it the square root of 2x plus 3 and 3/2 as well. So that is the square root of 5x minus 1 raised to 3. In short, using the chain rule, and that's kind of long, I know, since we use the quotient rule in some algebraic manipulation, the rules now, or the result or the first derivative of the given function earlier is this one. Negative 17 all over 2 times the square root of 2x plus 3 times the square root of the quantity of 5x minus 1 raised to 3. That's how everything works using chain rule. We are not only using chain rule here, your algebra knowledge in doing some things are very appropriate or very useful in solving such. Okay, so this is chain rule level 2.